Hi, and thanks for joining me for the CNC Fundamentals video looking at tool offsets. Each tool in a CNC machine needs to have some information stored about it so that when the tool is used to do any cutting, the machine knows where to position the tool for it to make the cuts in the locations calculated by Fusion 360. Some of the specifics about how we define a tool can include things like the diameter of the tool, the corner radius, if it has one, and how long the tool is. Knowing how long a tool is known as the tool length offset. Let's now look close at this particular machine behind us that we have in our Birmingham Technology Centre. The only point that a machine knows about is the datum point on the spindle nose. Tool length offset is the difference between the spindle nose and the tip of the tool. Without a tool length offset value active, the spindle nose will be driven to the points defined by the tool paths in Fusion 360, which is obviously not what we want, as this would cause potential machine damage, breaking of the spindle, damage the accuracy of the machine, cause it to be out of alignment, or even cause you to scrap your machine part. Here we have two separate holder types. One is an HSK 63 and the other a BT 40. Both fit into various machines, clamp the tool in different ways, but crucially have different lengths. Coupled with the fact that I can have the tool sticking out of the holder by varying amounts, means it's more important than ever to make sure that our tool length offset is set correctly. So we use the tool length to effectively offset the spindle nose back from this position by the length of the tool. So that is instead the tip of the tool that is driven to these points instead of the spindle nose. Tool length offset enables a CNC machine to compensate for many tools of different lengths and allows a machinist to set a Z-axis datum on a part and use multiple tools without having to reset the Z datum for each tool used. Different controllers will have slight variations on where their tool length offsets are stored. On the controller next to me, the Heidenhain, what we do to access the tool length offset table is click on the Tool Library button. From there, we can see a list of all the tools we have stored in the machine. On a Haas NGC controller, it's slightly different. There, we press the Offset button to take us to the Tool Offset table. So you're probably wondering how we set the tool length offset of a tool. Well, there are many ways in which this can be achieved. So for example, on machines like the one we have behind us, they have a various array of different tool setting options. One is a laser tool setter. The second is a mechanical tool setter. And the third is the option to use a slip gauge with a known calibration tool. When we're wanting to set our tools not on the machine, we can use very specialized tools like, for example, an optical tool setter. Now on this particular machine behind me, we have a laser tool setter. It has the benefit of eliminating manual setup operations and gives us a consistent and accurate result. On other machines, for example on the Haas machine, we have a mechanical tool setter. Each have their own advantages and disadvantages, but both are usually very accurate and consistent. Optical tool setters are very useful on routers and machines that don't have their own tool setters equipped. These have the benefit of high accuracy, but require manual input into the controller. Slip gauges, the least accurate of them all, can be used again on all of the machines, however again require manual input into the controller. On newer, more modern machines, you will see this approach used less often. Lastly, it's important to note that as we simulate our toolpaths in Fusion 360, we need to also make sure that the tool library has also those corresponding tool length offset values set within the tool library. This will make simulation and the NC output more accurate. This model consists of various surfaces machined at differing angles. As you can see, all of the surfaces appear smooth with no blend issues between the surfaces. I've now adjusted the offset of the tool by minus 0.5 millimeters. What this means is that the controller now thinks the tool is shorter than it already is. and thus pushes the tool further into the part by 0.5 millimeters. As we can see, having the correct tool length offset is crucial to getting the correct and accurate finish required on machine parts. For more information on some of the other fundamentals we've done in the series, please look in the description below or visit www.autodesk.com for more information.